Hello, good afternoon, everybody. It is 4:20, so we're going to start this session now. Thank you for everyone who showed up. I think it's a pretty good turnout. And I shouldn't have put my glasses away because I'm going to read the titles. These are unusual titles for us. They are very descriptive, but I'll try to read each one of them. I don't want to take any shortcuts. So the first talk will be 3D flow opera for level 1 trigger, a breakthrough invention capable of extracting all valuable information from radiation, providing a very powerful tool to discover new particles, reduce HEP costs, advance science, benefit humanity. All the talks in this session will be given by Dr. Crosetto, and he is with the Crosetto Foundation for the Reduction of Cancer Deaths. You may begin. Thank you.
Thank you, Lorenzo Fabris and Stefan Ritt and Sarah Pozzi for allowing me to give this presentation. So I start with a little bit of history. The history is the problem at CERN, that how it appears on the History Channel before 2008. That was data arriving at 800 million events per second, that now is over 1 billion. And here you can play the video, okay? So that it says if we try to save the data on a hard drive, in one day we'll fill up all the hard drive of the planet. And that was in 2008. Now, what happened? We needed then a decision unit that is capable of accepting a data stream, very high speed data stream, and cannot store it in a memory, but needs to process and try to select the best 100 events per second. Now, what are the algorithms, the filter to decide whether to filter this data or to put it on save it? So that is called a trigger, and each experiment, Atlas, CMS, LHCb, Alice, and at the Super Collider, SDC, and so on, they had different algorithms. Fermilab, D0 had that algorithm that are some common operation. CERN Atlas is a 4x4, excuse me, I missed it. This is a CMS and this is Atlas. 4x4 and 3x3 for a CMS. So what I did, I studied the algorithm, and where I came from, when I was at CERN, employed by CERN as scientific associate in 1989-90, I designed this board that you can see right here, this one, FD fast data processing for the second level trigger, because the second level you can already be able to make some program. But then I got specialized on learning on architecture. And by presenting at ECFA in Haken for the future Hadron Collider, people start to know me, and I was invited to the CERN School of Computing to give a lecture as considered one of the knowledgeable on architecture for processor. So what I did, I studied different architecture, DSP, RISC, CISC, transputer, microcontroller, embedded controller. CISC is the one on the Intel 8086 at that time, and try to represent the structure, the architecture, and learning from different architecture, say why we need all this architecture, because each one is target to solve a specific problem. At that point, I said, is there one of these that will fit for level 1 trigger? for executing those algorithms that I showed before. There was none, okay? There was the transputer, was a connection, but it was slow. There was the TMS from Texas Instrument, 320C40, but it was not. So at the end, I decided to design my own processor, that is this one, that is particular because, well, inside I put 4 data buses, 3 ring buses, and the laptop port, north, east, west, south, top and bottom. And this is how I represent in a simple way, okay? And so what was the, the goal? The goal objective was to provide experimental physicists with the powerful tools to offer flexibility to execute their dream algorithm with no limitation, capable of accurately detecting all possible valid signals from particle collision. This tool enables real-time execution of programmable, uninterrupted pattern recognition algorithm with neighboring data exchange with no boundary and no dead time. It allows processing data set for a time longer than the time interval between 2 consecutive input data sets with 0 dead time, extracting all information. So that was 1992. In less than 1 year, I came up with this architecture that really made a revolution, because before my architecture, my invention, how did they solve the problem Atlas, CMS? They were hard coding, cable, logic, the algorithm. But because the data was coming after 25 nanoseconds, they had to limit, say, okay, we cannot make many operation. And they were trying to use transistor ECL logic and gallium arsenide and very fast logic, high power consumption. And at the end here at ANSI, Atlas, they presented this was 7 steps. And I wanted to overcome that boundary, that limit of 7 steps. I said, well, in my processor, I allow to execute 26 operations, because I made a very parallel architecture, several ALU, multiplier. So in one cycle, 2.5 nanoseconds, they could execute up to 26 operations. But that was not enough, because these physicists, they said, well, we want more. We want to execute an algorithm, not only 7 steps, not only 10 steps, but more. And at that point, so these are the typical algorithm in a calorimeter, okay? That typically is exchanging data with neighbors. And for that, I made the port that are communicating with the neighbor. So my task was not to do something good for me to get the primary. No, I said I want to serve the experimental physicists, giving them the possibility to execute whatever algorithm they like in a computer, okay? And don't worry about the data that is coming after. And I explained this also to high school students, okay? So our focus should be on advancing science, fostering collaboration, environment, benefit of all, and not so. At the end, I came up with this structure, this architecture that is exchanging data with the neighbors, because the algorithm requires many data exchange. You see all this data exchange, and this is a typical algorithm. But I could not, even if I have the clock at 2.5 nanoseconds, I can execute 10 steps, each step up to 26 operations, but because 25 nanoseconds is a bunch crossing, okay? So, but you see that for executing this algorithm, where I need a 3x3, 4x4, 5x5 to find the electron, a 3x3, then if you want a jet, you need to get the data from a 7x7, and so at the end, I said, well, they would like maybe to execute more than 10 steps. So we cannot make a processor faster than 2.5 nanoseconds, means 400 megahertz, okay? So at this point, I compare, because the typical thing is a parallel processing, means you send the data from one source to one unit, and then you send it to the second, the third, the fourth, the fifth, and then this has 5 times the execution time, and then it sends it back. But because I am a hardware designer, I know all the implication that if you need to make a driver that is driving 4 loads, 5 loads, then it's consuming power. And not only, but this distance, it becomes longer than this one. And you come to a problem on real estate of the circuit on the board, because I designed the board and everything. So considering all this, I came up with the architecture that the key invention is the bypass switch and bypass register, okay? So this will allow, ideally, for the scientist to take as input all data from pads, from detector, from electromagnetic calorimeter, hadron calorimeter, okay? So putting everything in one processor, then this processor is exchanging with the other processor, but how can we solve the problem of the time required to execute the algorithm and the data arriving every 25 minutes? Is the bypass switch. And this is the bypass switch. So what I do, the first data I explain to the students in a corridor of 5 classes. I say, if you have an envelope that arrives every 6 seconds, and you need to solve a problem of, on each envelope for 30 seconds, then the first envelope, you give it to the class. The second envelope, you pass it to a box that is in between the first and second class. You pass the third, you pass the fourth, you pass the fifth, and the sixth. You give it to the class, you take the result, you put it in the box, and data and result are flowing through the corridor in this way. So you see that the number 1, if you follow the number 1, stays 5 times on the processor here, number 1, and while the other I bypass, and each person, I go back. So this is architecture, okay? So this is the 1995-98. I implemented this on, and I presented on a peer-reviewed journal, Nuclear Instrument and Method in Physics Research, an article of 45 pages. Compared to the trigger of CMS is a comparison of 1 room of the CMS with a box. I could put everything, and this is the difference on the back panel, okay? And this is the test of the prototype on FPGA presented at the IEEE in California. This is the board built on FPGA. So the other thing is important. What is the result of not using my system is that in 2012, that has been adopted the FPGA, then out of 100,000 Higgs boson-like particles generated by LHC, only 40 have been detected. Okay, this could be designed, and so now what we have to discuss still now, this was 2023, I discussed with experts of Trigger, Atlas, and CMS at the other conference, IEEE. We need to compare this architecture, that is the one that I show you in the third slides, with this architecture and the bypass switches, okay? This is, to solve this, is necessary to have the CERN Director General allows me to discuss not for 15 minutes, but for 1 day, like I did at Fermilab, with all the experts of the trigger and also the DOE that is funding this project to discuss with them, and then we converge in a thing. So this is the scientist must rigorously, what I can do, I need to demonstrate the technological benefit of an invention. And then I cannot convince my colleague about the advantages, benefit of an idea or an invention. My task is to demonstrate that is a solid scientific basic and then inform the world. If we get to the point that CERN has spent $100 million to develop trigger with FPGA that were able to find 40 Higgs boson event-like out of 100,000 because of the limitation of the FPGA, instead with mine, there is no limitation because, as I told the high school students, if now the rate of input, like the LHC, is increasing, then instead of 5 classes, I put 10 classes, 5 classes down the road, and I have all the, I can satisfy the requirement of analyzing each event for the time that is needed, that is desired by the experimental physicist. Thank you. Now I am taking questions.
Thank you very much, and thank you for being on schedule. I remind the audience that we're using Slido for questions, like all other sessions, so if you have questions, do post them.
But we also accept questions from the floor. If you want to
Yes.
stand up, that's also okay.
Just identify yourself. If you have a question, we'll come to you with the microphone. All right?
Well, if there's no question, I have one question there. You have this 3D structure, and the thing is much, much smaller than the other trigger system. How do you solve the cooling? I mean, if you get the power and then you have a 3D structure, the layer in the middle, how you cool them?
Okay. I have done all the simulation, and I have implemented this in 3 FPGA and 1 standard cell, okay? And the FPGA, it allows me the board that you have seen that is working. It has a 16 channel, okay? And that board, it can fit into an integrated circuit, okay, that is consuming 10 times less, is 13 times the speed, and I have calculated with, by the way, I have here 59 quotes from the company to design the board, that I designed the board and the integrated circuit. Okay, so the integrated circuit, there is the power consumption, everything is calculated, defined at the level of the integrated circuit, level of the board, and at the level of the crate. That is within the limit of the power consumption of the crate, the board, and after 9 years, because I got a lot of company, including Samtec and so on, who made the simulation, even the crosstalk of the connector of the Twin-X cable, and they provided all this simulation that there was no crosstalk, everything looked fine and so on. And after 9 years, nobody looked at this great work that involved a lot of engineers of many companies that work for free.
Okay, good. Thank you for the answer.
Thank you.
More questions? There's one over there.
Hello. Is it on? Yep. Okay. I would like to understand the inputs and the outputs. Like, how do you get all the data inside? Like, we have trillions of pixels, and do they all have one input, or are there different? Is there a different number of channels at the input of your device? It's unclear to me how it would work exactly.
Thank you for the question. This is exactly the limitation, the main limitation that for all the other processors that I listed before. And some people, when they look at the structure of my drawing, they said, oh, but this is an hypercube. So no, it's not an hypercube, because you cannot get a stream of data of 1 billion event per second in an hypercube, okay? Once you have in the hypercube, then we can crank the number, but the bottleneck is getting the need. So I have, as you see, 4 bidirectional port, north, east, west, south. And I have a top and bottom, okay? Those are unidirectional. There is a FIFO for de-randomizing the data on the top, and there is a register on the bottom, okay? And so I can sustain any input data rate. There it was 80 megahertz. That is twice as much, because at some point we were talking about LHC going at a higher speed. Instead, they remain at 40 megahertz, okay? But I can sustain more. So there is a FIFO de-randomizing buffering at the input for the top. And then all the data with the exchange with the neighbor are processed, and the result is going to the bottom. The bottom, it goes to a pyramid of a 3D4 processor that are funneling the data from thousands of channels, 4,000 channels, to a single channel. All this has been simulated in detail. I will present it in the next talk, the simulation and everything.
Thank you.
Okay. I think we should proceed now with the second talk. This is also about 3D Flow Opera. And the title is 3D Flow Opera, a revolutionary electronic instrument maximizing performance, flexibility, and cost effectiveness for detection and imaging technology.
Okay, so having addressed the problem of a very high data stream and processing the data stream for a time longer than the time interval between 2 pictures, 2 set of data, okay? Then we can solve many applications. The application in high energy physics, be more efficient of detecting not only 4 Higgs boson every 100,000, but more than that. And in medical imaging, it's even more important than physics, because the radiation that is emitted from the patient, if we have an efficient way to detect it, then we reduce the radiation and we find all the photons means a small tumor, okay? And then the other advantage is at low cost. And also in streaming of data at a very high rate to detect people or detect object, any object, okay? So this is the concept, a simulation of the box that is the 3D flow, that is receiving the data from hadron calorimeter, electronic calorimeter, from the pad, from the muon, from different detector. And the idea is to take all the data within a viewpoint from the interaction of the beam, okay? Then when this data goes into the processor, they are exchanged with the neighboring processor and and the physicist, the experimental physicist, can use the equation, the algorithm that he likes to filter to the one that he thinks more theoretically was better. Okay, so here is the example that can run the algorithm number 1, 4x4 from Atlas, the 3x3 from CMS, and the one for LHCb, and also tracking. Okay. And then here is the result with the pyramid that you need to study that, how I implement the pyramid, is putting the photons in bucket, electron in another bucket, and hadron in another bucket. And all the, okay. So I received $1 million from the Department of Energy in 1995 to make a feasibility study. And so we developed a lot of things using the top consultant in the world, like Synopsys for designing the ASIC and calculating and porting to a technology TSMC from Taiwan. And so these are all the different elements that have been developed, software to develop a system. And this is the flow of the previous component that so is designed in real time. So I developed the assembler, the simulator, the one that is comparing, because the simulator are the first at the C++ level that is simulating with a behavioral model the entire system with 10,000, 50,000 processors. Then the same model is being coded in VHDL for 4 processors, and then that is simulated on the VHDL at very low level, at the transistor level, okay? Then both the one of the VHDL and the one of C++ are generating text vector. And then I compare it to the text vector to see that there is a match. And okay, so this is the simulator. The simulator allows me to simulate the algorithm, taking data from from a memory, and then it allows me to see all the units that I said, internal unit, ALU, multiplier, and internal to the buses also of the processor. And this is the structure of the bypass switch. Bypass switch, that is the key invention with the bypass register that allows me to have an implementation point-to-point instead of a star, because a point-to-point, I'm using LVDS, low voltage differential signal. That means the current goes in one direction or another direction and doesn't create the spikes on the power supply. Because when I came up with the idea, I said, oh, you have too many signals commuting at the same time, you will have a big noise on the power supply, this will never work. Instead, the first time that I build the 2 boards and I make it communicate, it works. And so there is all the simulation. And this is the system test bench, means a test bench simulating in C++, and then simulating on VHDL at low level, and generating text vector and matching and comparing the text vector. Implementation. Implementation, we have 2 crates. One crate is ATCA with a blade from one side is taking the signal from the detectors, CMS, Atlas, and so on, convert it, reform the event, because all these different detectors, they are streaming the data with different, we will see it here, okay? So if we look at the different detector, they are streaming the data with different way, with 4 gigabit, 10 gigabit, fiber channel, PCI, Infinity, SATA, FireWire, USB, and so on. But in this backboard, the data are coming from different detector, sub-detector, let's say, and they should form the word, so rebuild the event, the one at the same timestamp. After having done that, is going through the back panel to the front board that is packaging the event that before instead it was the sub-detector, and the event, it goes to the box of the 3D flow. And that it should be a reasonable distance, 50 centimeter, because at that point I needed to have a time consistent, and so that is, okay, so this is a detail. Usually the picture that you saw before is here, the overall system, and this crate, it fits there, okay? So we have a board where is receiving data from sub-detector and rebuilding the event, putting all the pieces of information of different sub-detector in a single word, and then pushing the word to this, and this is generating the correct signal to send it to the, and now, when I design something, I always keep in mind that I need to test what I design in a lab. It's not just building and then trying at the experiment if it works or doesn't work. So this is the test bench. The test bench means that I need to test the real stream of data. So I take a 2-channel waveform generator, and here I have the part number and everything at 23, even the cost. And then this is the form of the signal and the 4-channel, 4 gigahertz oscilloscope. So I am testing 2 channels at a time to make sure that all the chain is feasible in hardware, is not just practical. Then, though it's not just theoretical. Then I would like to test the data stream from what is supposed to be the detector, and my detector is a memory, and I build a board and I design the board that are capable, each board 40 gigabytes per second streaming in here, because remember, the problem to solve is a high data stream, that we cannot save data on hard drive because it's filling the hard drive of the planet. So we need to create this high-speed data stream and filter the data. So what do we put in this memory? We can, by software, create algorithm that create events with Higgs boson and without Higgs boson with a lot of noise. Or now that we have Higgs boson event, we can just put in the memory Higgs boson event and then push it, and we have a Higgs boson event every 10 billion events. So that is the rate of Higgs boson. So, and then with all the system, the 3D flow system here, with the algorithm, we have to find the capability. The system should be capable of filtering the data that are coming. So at this point, I provide a system that can be tested on the lab, and we will not have surprise when we will install this in the field. This is the design of the board. By the way, there is all the detailed design of the board with the chip, with everything, and this because I couldn't make a publication. They are all in patents. So if you go to my patent, you see the design of all the boards and everything, okay? And again, this board, this board in the system, it fits there. We have, this is the crate, VXI crate for the 3D flow, and this is the ATCA crate with the blade to rebuild the thing. Now, also the cable. I spend pays a lot of care to design the cable, to test it, to simulate it. I saw here at the industrial exhibition, Samtech, and I congratulated them. He said they were very nice because I provided them the pin assignment with the ground. You see the green is the ground that is isolating the signals. And they simulated for me using their twin-ax cable. So I look at the characteristics of the cable, the speed, and see. So a lot of work to validate, to show that this is feasible. And so this board with this cable is sitting in my system over there. And this is the memory. I told you that I need to simulate the detector on the test bench, on the lab. Okay, so on the laboratory, at this point, simulating the detector, I created and designed using excilinks for the control and the memory. I picked the memory with the right characteristic and designed the very detailed. Also, this is on patent, but the patent, if I don't have the money to protect it, is fresh water under the bridge, okay? So this is a 40 gigabyte per second per board. I put 16 boards, and so I get to 100 gigabytes per second. So this is the timeline, all the boards, the integrated circuit with all the quotes that I have from 59 different quotes from 21 companies, more than one quote for each component because there should be competition. And so this is stagger all the different construction of the board and the testing and cables and so on. And in 2 years, I have the system ready. And then the rest is for software and testing and maintenance and so on, okay? So, story. 1993, I made the invention, was recognized by a major public scientific review at Fermilab, where there was also a representative from CERN, from the industry, in 1999, after receiving $1 million for the feasibility study, I provided the result in a 45-page nuclear instrument and method article peer review. In 2015, I presented this project, very detailed feasibility with all the data from 59 quote and so on. And 2024, I thank the organizer for letting me present this. 2025, we could make a box. Okay, sorry, this was the last one. Let me go back. Okay, so I would say there would be, hopefully, if I get the funding, we can reduce in the box what it has been made in the past in a room by CMS, and that it was dismissed in 2016. And on the first talk of this conference on Monday, I heard, unfortunately, that they are still looking at FPGA. And my simple question that I met the lady who gave the talk just outside before this talk, and I asked her, but why Intel is not making a Pentium in FPGA? Why ARM processor is not in FPGA? Why all these other processors are not in FPGA? Because we are designing a special architecture that is programmable, but is targeted to a specific application, okay? Here, I need a high data stream that none of these processors are satisfying this very high data stream that I resolve, and thank you for the question, with a FIFO at the input that is de-randomizing, and then with the possibility of the bypass switches that allows me to handle a data rate higher than the length of the algorithm. Thank you.
Thank you, Dario. So we have a couple of questions online. The first one is, what is the expected cost for a setup using this technology?
Expected cost of?
Of a setup using this technology.
Okay, I have the detail in the 300 pages, 274 pages proposal supported by this. The cost for development is 13 million, but after the first development that will serve several experiments, CMS, Atlas, LHCb, and so on, each box, each unit with 8,000 channels, that was typical at that time. Now we can increase, but you have a reference of cost, okay? 8,000 channels that can sustain 40 megahertz input with many steps is $100,000. $100,000 for a box full in production. That is the cost, and I have the quote of the production cost of the board, of the chip, and everything. Now, what I heard this morning, Monday morning, it was that they would like to put an FPGA, but the processor is going to cost $1 per processor, okay? Because it can put now maybe 128, but at that time in 2015 was 64. So when you get $1 per processor, and that is not the main things, the cost and the speed, but it's the power consumption. Because in a sea of gate of FPGA, you have a lot of power that needs to power the gates. In mine, I need to power 100,000 gates that the power required is much less, and so by keeping the power low, I can make a good calculation and satisfy without cooling with water, just air cooling is fine with the normal crate of Wiener or Caen. I can meet their specification.
Okay, thank you. Next question. What criteria do you use to filter Higgs and non-Higgs events? What criteria do you use to filter Higgs and non-Higgs events?
I don't understand.
Higgs event, you know, when you had your processor, you said the Higgs events go there and the non-Higgs events go in the other bin. How do you filter between Higgs events containing a Higgs particle and events containing not a Higgs particle? How do you filter between them?
How do I filter the...
Yeah, you had this picture where you had these bins and then you put Higgs event in one bin. That's how your triggering works, right?
Is it on
I
this
guess
one?
it was this one on right.
Ah, okay. So that is the pyramid, okay?
Mm-hmm.
So the pyramid is a funneling that it should go from 4,000 channels to 1 or to 3 channels, okay? And I am using 3D flow processor to funnel the data. And what I do, I create a word, and the word is a timestamp, and then the type of particle that has been detected, because at the front end, the stack of parallel processing is finding the particle, hadron, electron, and then it puts an information on the 64 words that is traveling through the pyramid and is going from every time is reduced 4 times, 1/4, okay, it goes to 1/4, and is going toward the end, and at the end, you can have 4 exit, or 1 exit, or 3 exit,
Yeah.
because it's
But I guess the question was, I mean, how do you distinguish for a Higgs event from a non-Higgs event online? Because you said you can take many Higgs events, much more Higgs events, so you have to recognize that it's a Higgs event.
Yes.
How do you do this online? Because I'm not an expert, but if I understand, the Higgs analysis is very complicated, has been done offline, with histogram, with statistical methods, very sophisticated. How can you do this online in your trigger?
Okay. Let's go to the origin, 1921. They had the possibility, they needed to put everything in 7 steps, okay? 7 steps algorithm, and typically what it was calculating the total energy and making a cut, a threshold. That was the way to reject event and say, well, this is a good candidate, okay? With mine, I say, come up with any algorithm that you want, because I allow you to execute a time longer than the time interval, okay? So at that point, I don't see the problem is solved by the fact that I give the possibility to execute the algorithm to find the electron. To find the electron is front to back, that the energy should be on the front on the electromagnetic calorimeter and nothing on the hadronic calorimeter, and that you define, okay, that is most candidate for an electron. For an hadron, instead, there is less on the electronic, there is more on the hadronic, and so you select the different particle executing the algorithm, and then you tag, you have a few bits that is telling you hadron, electron, or photons, or muon, or other things. But you do it at the level of the algorithm, and then when you have found something, you just code that into 2 bits for 4 different codes.
Okay, good, thank you. Then one more question, then we run out of time. Regarding your simulation, you have shown this nice simulation. Regarding your simulation, is the source code for this program publicly available, and can it be used to verify other architectures?
It can be, no, it is coded for the model of the 3D flow. Mm-hmm. So the 3D flow is a very well-defined model, has 4 core buses, 3 ring buses to exchange the data, as an instruction set, And so there is the simulation C++ to simulate 10,000, 50,000 processor, how they interact and the
Okay.
data flow.
But it's
And there
limited
is-
to 3D. Okay.
Yes, and there yes, it is coded for the 3D flow, like, so it must be coded for
Okay,
something.
okay. Thank you. Sorry, excuse me.
All right. So yes, we're going to proceed now with the third talk, this time 3D CBS. The first true paradigm change in biomedical imaging invented 23 years ago, confirmed by measured results to enable a safe, very early life-saving cancer detection. Why hasn't been founded? Who is responsible for millions of needless deaths?
What does or what does not solve the cancer problem? So we know that the most deadly calamity, I'm talking about premature cancer death, because we must die of something. So if the heart is failing more than that is because it is worn out, okay? But we have to talk about premature cancer death. So let's look at the data of below 74 years of age, and cancer is the most deadly and costly calamity, $1.5 trillion per year. Do we know what it does or not? Yes, we know, okay? Does data support this finding? Yes, we have a lot of data that early cancer detection, and this is the comparison among countries, okay? The best methods to detect is, we know that cancer has a mutation in temperature, conductivity, metabolism, enzyme, odor. That's also the reason why they put dogs to smell and to detect cancer, because it's changing odor. But obviously it's not the best way and scientific way to reliable to find tumor, okay? Can we prove what is the best measure? Yeah. To prove it, anybody who comes with an idea, even with the snake oil, just show me that you take an area with 10,000 people and prove your theory, your 3D CBS, your drugs or vaccine, whatever, and just show me that it's reducing cancer death. And even if I don't understand all the detail, I will believe it, okay? So what should be improved? We should improve early cancer detection, and so on. So let's go back on what is PET. PET, we have the first data in 1948, and look at the people who came out with the idea. They were looking at number, because PET is measuring a variable on time. So they were comparing and say, okay, there must be something going on in this area because the numbers are higher, and is higher than this other area. But they didn't provide a picture inside the body and so on. That is what PET is measuring, a variable on time. And so we have all this in history that I took it from a courtesy from Steve Webb. So that the essence was missed. The 3D CBS provides the missing tool for effective early cancer detection. It is an advanced PET-CT with a detector 1.5 meter long, covering all organs of the body, okay? Designed, first presented by myself in Lyon, France, in the year 2000, with a book that is available free of charge there, and make the simulation. The proof of concept was tested in hardware in 2001, presented at the IEEE conference in San Diego, and 2003 on a board at the conference. You can look at the video that is describing. So what is the social objective? Reduce cancer death and cost. We need to look at our objective that is, in order to do this, we need to accurately extract from radiation and measure all possible valuable signal related to the tumor marker at the lowest cost per valid signal capture compared to alternative approaches. So the ultra-sensitive 3D CBS has these 4 features that nobody else has at the same time, that is effective early cancer detection with an activity less than 150 million becquerel demonstrated by calculation, a radiation dose and then proven by others, by third party on a hardware, dose of 2.5% of the current PET, 2-minute effective screening, a very low examination cost, okay? So it's this, this is replacing mammogram, pap test, and smear. So what happened in PET? What happened in 1998 is that money continued to flow to projects focusing on the improvement of spatial resolution to the detriment of sensitivity. We just said that it's measuring a signal within the number, in a variable, in a time unit, okay? So year after year, I keep repeating that instead the PET is measuring sensitivity. I had a meeting in 2002 with the president of nuclear medicine of Siemens and the director of PET. And we spend, I will tell more, okay, this is the meeting in 2000. They said, no, we cannot improve the efficiency of our PET because I wrote the book, this book, the title is 400 time improvement of PET efficiency. And they came to my place in DeSoto because they could not believe it. They said, well, we are the largest producer of manufacturers, so it's not possible. I said, well, it is possible if you improve the electronics. And they said no, but 7 years later, I was right, and they put on their website that they improved the electronic. And in 2018, at that time, I also said, if you increase the field of view, you will get, for an linear increase, you get the square of the number of signal from the tumor marker, from the photons, okay? Anyway, so 1948, they were presenting this number. I'm sure that they didn't have a technology to detect all the photons, 511 kiloelectron volt in opposition coming out of the body. And so I said, where are these photons lost? So the photons, and then I compare the photon of the current PET at that time, 16 centimeter field of view, with the 3D CBS 1.5 meter. And I see that there is obviously, for geometry, the field of view, the solid angle. Crystal was not a big problem. Crystal can be the same for all of it. But the bottleneck, it was the electronic. The electronic that was not efficient to detect all these photons, that is particle. And my experience in particle physics for 20 years, that is what, and the invention of the 3D flow, that is what it comes into the play, okay? So the second technical objective, we look at about the social objective. Technical objective say, well, how do I get to the social objective? With a technical objective of improving the measurement of the photon total energy, photon arrival time, coordinate X and Y, and the Z coordinate with the depth of interaction, and efficiently filter out all the background radiation. That is the 3D flow that allows me to execute a complex algorithm that are filtering all the background, okay? So this is again the way of a sample of algorithm that is taking data from the neighbor. Why? Because I want to build the total energy. I want to make sure that is a 511 kiloelectron volt. That is not a scattering. So I can even take the data depending on the size of the sensor, 3 by 3, 4 by 4, 5 by 5, to make a good energy resolution. Then, and so this is the way I'm doing, that is different and overcoming the limitation of the Anger logic 2 by 2. Each element is a central element, can detect if it is a cluster, and then also make the interpolation to XY, and for the depth of interaction at that time in the year 2000. These are all figures from my book, okay? So there was several techniques to measure the depth of interaction. My system could implement all of them because it's a programmable algorithm that it allows to program all of that. So in summary, what is the difference? Current path, long examination time, less than 2 minutes, and then examination cost also much lower, and radiation very low that can be repeated, and efficiency and measurement quantitative and not qualitative. So not a qualitative things of black and white and gray, but numbers, okay? We are going back to the 1948, okay? The principle, that was the right one. So this is a logical layout of the 3D CBS, the barrel of the detector, unroll it, and you get a matrix. You go, this goes to a stack of a 3D flow that goes through the pyramid after finding the pair of the single photons, 511 kiloton volt, and then it's going to match the photon, and you find all this has been implemented in hardware. The board with 1,200 3D flow processors, and this is going to a chip, the thing that I developed in FPGA, that I tested and worked, so the prerequisite is there. These are the boards, so everything is in 2 crates. 1 crate with the 3D flow, and the other crate, and everything has been calculated, power dissipation and so on, with the PET detector and the ADC converter and the signal in digital through, I will show you, by the way, what is on the board now, it goes into a chip in 2015. Now, and now it may be even less. So the 3D CBS comparison with Explorer, here are the author of the Explorer, and we have, they are using expensive LSO crystal. I'm using BGO, 3,000 instead of $500,000. And then the capability of handling data, 40 terabyte, I have more than 40,000 terabyte I can handle in 1 day. The result, they have result in 40 terabyte. I am taking this from the publication of the Explorer, and they were confirmed at the conference in 2016 in Strasbourg, when I talked to the designer one who were implementing the Explorer, and cannot save millions of lives because is not efficiency enough. So this is obviously it's difficult to read and now all this, but I provided the link to a newspaper in Dallas that was published in Dallas for a big pages tableau that are explaining all this, and is showing also the difference in radiation between the Explorer and the 3D flow. So the bottom line is funding agency that cannot invalidate a demonstration of an invention benefiting have a responsibility to fund an experiment to serve as the final judge, because we cannot be judge in science, the absolute judge. The absolute judge is the result of the experiment. So if there is nobody who can invalidate theoretically or calculation any project, my project or any project, then there should be, with $2 trillion per year of research and development funding available to all of us, there should be also the possibility to fund an experiment and to let the judgment. And how do we judge the thing? Or we can test any PET detector, Siemens, GE, Explorer, Siemens BioQuadra, by putting a rod source in the middle of the detector, and then 1 millicurie of radiation, and see how many is collecting. And then placing a point source with 0.1 millicurie, and see how many photons have been detected out of the 3.7 million pair emitted in 400 seconds. So the device with the highest sensitivity, lower examination cost, lower device cost is best for saving lives, because less radiation to the patient, find the smallest tumor. Again, funding agency, just to make it okay.
Okay, thank you. So if we have one question from the audience. How does the number of false positive cancer detections in healthy tissue from this technique compare to conventional medical imaging techniques?
Okay. That's an important question, and thank you for asking. That was one of the first questions I said, well, a machine, even before the Explorer that came 2015, they received $15.5 million to build it, okay? They were saying, but a machine so sensitive, it will find anomalies everywhere in the body. And there will be so many false positives. I say, well, that is exactly, by the way, I went through, and I will show later, one of these tests, because I had a tumor that luckily has been removed, and I'm safe, okay? But I said, the first test, the first exam, the doctor should not take any action, no false positive. Just use it as a reference. And then take a second test with the same machine, same protocol, same radiation dose, increased by the weight, or decrease of the body, because it goes by the weight of the body, the radiation, okay? And then subtract the first image and see if there is some hot spot, something that's increasing. And for this, we have here my partner that she had a tumor that was developed in, the surgeon said, 4 to 10 years. And when she got some symptoms, it was 3 big, from 10 to 14 centimeter, not millimeter, 4 centimeter tumor they removed. But the surgeon said, yes, on the abdomen. You had this for 4 to 10 years. So the answer to the question to rule out false positive is to make exam, and the doctor will decide whether to make a repetitive exam every 6 months, every year, every 2 years, okay? If there is nothing major in the detection, then it can do it after 2 years, after 1 year. But if there is something suspicious, it can request an exam after 6 months, because the radiation dose is less than the one received by a pilot in 1 month. So you can even repeat every month, because it's less than a pilot, the one that received by a pilot, okay? So by looking at the trend, not at the single exam, and I will never take action on the exam that I had the 1st of December 2023 on the Explorer at Grand Rapids, okay? But only the trend, it should help the doctor to reduce the false positive and save the lives and intervene the time that he see that there is an excessive increase in activity in some area of the body, and he will have to investigate.
Okay, thank you. So you're running behind time, so let's thank the speaker again.
All right, and we are running about 10 minutes late for your information. Apologies for that. We're going to now head into the third talk, also about 3D complete body scan. Title is Features, Implementation, and Usage Targeted to Reduce More than 50% of Premature Cancer Deaths and Costs.
Okay. Here is the summary. Again, the 3D CBS invention. The starting point is this table that says that prostate is early detection, 100% survival rate, breast cancer, 98% survival rate, colon, 81 survival rate, and lung, 49.5 survival rate. So knowing that by chance, when a person is detecting cancer at an early stage, has a greater chance to survive. Instead, for the lung, for instance, late detection is 2.8 survival rate. So based on this book, replacing all this screening test, investigating where the photons are lost, and means the signal from the tumor markers, creating, and this again in a patent because I couldn't publish, it was not accepted, the 3D CBS, all the different detail of the construction, field of view 157 centimeter, tested and prove feasibility in hardware and with the architecture. Where are the innovation? The innovation are in the electronics. That is, it allows two things. One, to change the assembly of the detector and also the algorithm. So usually when you make an invention, you open the door to other inventions, okay? And this is the case. So again, this is the implementation and benefit from this invention. The construction is summarized here in one slide. So we have two crates, one crate with 9 boards, 8 for the data acquisition, that is the stack, that is the green part, okay? And one for the pyramid. The pyramid is the funneling from 2,000 channel to 1 channel, okay? And then I have, again, the simulation of the connector, the cable, the twin-ax shielded cables. The connector, you see that has a different layout. Also, this has been simulated kindly by Semtech for free. And then I made a design of the board with a cable that are different from the previous version for the high energy physics, and to transfer the data from the analog to digital converter to the system. And at the end, this is the result, that we will have a number. We will not have a qualitative information, but quantitative information. This is the design of the board on VME. The other one was in VXI, 256 channel per board. The board are sitting there and converting the thing on a chip. This is the timeline of the development. Again, in 2 years, I have 2 of these devices that can be built by taking the delivery of the hardware that I have from the quote. The quote, they tell me how long will it take to build the board, to build the ASIC, and staggering them in a way that is acceptable. And the astonishing thing is the cost of all the components of the 3D CBS is $2 million. So if the cost is $2 million, I envision to have a selling cost, a cost to the consumer, to the hospital of $3.5 million, almost double, okay? And just a few months ago, on May 2024, in Italy, and I am Italian, they purchased an Explorer for 21 million euro, and they were proud to announce this. And the fact is that in 2008, I spent hours in several hospitals in Italy, including this one, explaining that by increasing the field of view is increasing and they said, no, that we don't need that, we don't need that. And then at the end, they buy a machine with $21 million that I provided all the information, demonstration that could be built and get it for $3.5 million. And now they will have to pay $1 million for the thing. Now, people are asking me, how can you calculate and determine that the cost of the examination is $200? Okay, this is the way, and I would like to have any input, any comment on this from anyone in the audience. For such a machine that I consider $3.5 million, one should envision 2 shifts of 8 hours each. If for the vaccine we had a throughput of people incredible that they could vaccine millions of people all the world, it's not impossible to do this. That will take 2 minutes. And I refer to the data that have been provided by United Imaging that they were going to have a throughput in out of the bed in 2 minutes with the Explorer. So by looking at this, I envision to have 48 professionals needed for each day. Okay, now I cannot do it anymore. I don't know why. Anyway, the chief administrator, $150 per hour. I just tell you the rate per hour, and anybody who would like to comment, if it's not reasonable, I will change it, and the result is not changing very much. 3 secretaries for $50 per hour, 2 administration secretary, $50 per hour, 2 personal logistic officer, $50, 4 nurses, $75 per hour, technology, $65, 10 doctors per shift, $200 per hour, considering a salary of $400,000. That is pretty high. In Italy, it's much less than that. It's $45,000. Okay, and so then I calculated the time required to read the screening, 22 minutes, and instead of 68 minutes for a workup, because each day I envision 360 screening tests of 2 minutes, and 4 workup clinical tests for the less fortunate people who have a suspected tumor, and they need a more in-depth investigation of 15 minutes or even 30 minutes and so on. So that will take 68 minutes. So for a total of the professional cost of $46,000. To this one is adding the cost of the radioisotope, the maintenance cost, $2,000, the cost of the renting space, $1,200, and amortization in 4.5 years, 3.6, for a total of expenses, $58,000. If we set the price of the screening test, $200 times 360, and the 1,200 for the workups for the clinical, then we get an income of $81,000 with a margin of $23,000 for profit or whatever I forgot that you may help to remind me. Okay, so this is more detailed reasoning and justification of all these numbers. I refer to an article on Journal of Nuclear Medicine regarding the Explorer that the author of the Explorer wrote. They provided the result of their measurement, 5.7 million becquerel in 20 minutes. They said that images appear to be of diagnostic quality. So that is telling me with calculation that roughly is collecting 200 million signals. In mine, I consider to collect 250 million signals to be on the safe side. So the goal is to collect 250 million signal of accurate data, and that it will provide an image of diagnostic quality. So with all the calculation that you can find in my documents, then at the end you have a screening at $200 and the workups at $1,200 with a daily income of $81,000. Estimated, say, how can you estimate that is going to save 260 lives per year? Okay. So I am taking as reference the experimental data that are confirmed from World Health Organization, American Cancer Society, of the survival rate at 98% and so on, but I'm not claiming 98%. If I claim just 58% after 10 years, then I get to 260 lives saved per year based on the assuming a rate of death rate of 0.5%. Each machine can test 90,000 individuals in 1 year, and with this death rate that we have now, because we have 10 million people dying every year of cancer, 450 are expecting to die. So if we make 58% of 450 is 261. So this is my calculation that is conservative because it's not taking 98%, 89%, or 49%, but is taking 58% in average for all cancer. So this graph is showing the number of lives saved and cost every year. Obviously, it must be gradual because one cannot go from one machine one day and next year having 1,000 machines, but it should be a reasonable growth of a thing. And so there are, this table is accessible and it can be used for the Explorer, for a vaccine, for a drug, for other devices. You can change the formula, but it helps you to track down with the assumption, and the assumption is made on row 16, okay? That are those data that I refer to the WHO, and then this 261 people, 260 people saved per machine per year. So because there are 6 billion, and this is done for the United States, okay? 6 billion tests in 30 years, then gradually building 2,359 devices, 3D CBS, in 30 years is going to save more than 10 million lives and also $2 trillion. The other is the TB-CAD, the total body computer-aided diagnosis. That is changing making a revolution on the way of practicing medicine because it's not based in the diagnosis on a single test, but with the help of the TB CAD, is going to change it to the trend of several exams, not only, but it can create a big database that is comparing the disease of one person with a reference of millions of other things. Thank you.
Thank you, Dario. Now we are 8 minutes behind time, so I
got
would
2 minutes.
propose, in the interest of time, that we immediately proceed to the next presentation.
Very good. Thank you, Stefan. The next presentation, okay, thank you, is, which one is it? We're at number 4, right? 5. Yes, 5. So the title of this one is perfect. Over 39 million lives needlessly lost from cancer in the past 23 years, and 69 million more over the next 7 years, because scientists' goal for PET is to take beautiful picture and crush my invention to cost-effectively measure biophysiology.
We go again to make a restatement of the original definition of positron emission technology. By the way, I spoke with the inventor of the PET, Gordon Brunel, before he died. He passed away from the Massachusetts General Hospital. And I asked, why did you use tomography? There is no tomography here. The tomography is a good term for CAT scan, because tomography is from Greek, is the cut, is the slice. This is emission in all directions. He said, oh, it's all historical because we were using a reconstruction program from the CAT scan, and so we just used that name. So in fact, it should be changed to technology, not tomography. Anyway, it is a non-invasive imaging method used to obtain quantitative molecular information about abnormal biological process in the body. It is important to accurately measure and count within a given time the maximum number of signal pair of photons which are related to a physiological function, not anatomical like CAT scan, MRI, and so on, but some physiological. Again, if in 1948 they were able to get this picture and they were looking at the number, and based on the number they will determine where was the anomaly, now we have a much better tool to do that, okay? PET developer in the market took the wrong direction in 1998 by focusing on high spatial resolution and picosecond electronic to the detriment of sensitivity. They also focus on the use of expensive, rare earth crystals such as LSO, which increase the cost of the device. This is, if we reflect a little and we say, when we get the information from the weather forecast, are they showing us a high resolution of Texas and telling us, hey, look, with this high resolution, you can understand that you got more rain in this place than the other place? No, they give you a number. They give you in 6 hours, you got 0.2 inches of rain in Waco and 0.2 in Dallas, and so on. So, because it's measuring a variable in time. So we need to use the correct instrument to obtain the most accurate measurement. We have the ruler that makes a caliber, and the CAT scan that are measuring dimension. Okay? CAT scan is good to measure the dimension of the tumor, but in the 15th century, we have the wheel, the water wheel, the anemometer, and the PET. They are measuring a variable on time. So, no. Since 1995, I consistently advocated through seminars, articles that I also published. This is one that I presented at a conference in 2008 and was published in World Scientific in 2007 and was published in World Scientific 2008. and this is the reference. You can get the article where I made that clear example that PET is measuring a variable on time. And I was so glad that in 2021, Professor Joao Cannor, who was the plenary speaker at the conference is a virtual conference that we had in Japan, and the first slide and the last slide, he said, the goal of PET is to measure biophysiology, not to take beautiful pictures. I was thrilled that I used several times his slide, and he would use it as a take-home message. Okay, so again, you have seen this, that is the 3D CBS calculation and claim, and so as I said, in 2002, 2 years after publishing this book, the leader in the field, main producer, they were producing more than General Electric. They came to my place in DeSoto because they said, this is not possible. They thought that I was a dreamer, okay? And we spent 2 hours on this figure. And we went through all the calculation. At the end, they could not deny, and I made them realize that they were going in the wrong direction of the LSO crystal, because you don't need it. You need to have a crystal better than the sodium iodide that is very thick, so the density of LSO and BGO is the same. You need to count the photon, not to measure the spatial resolution. It is not the instrument characteristic. And they said, well, we cannot do that. We cannot improve the efficiency. And they stated there, by the way, our meeting, there was a one-day meeting, was recorded with the approval of all the people present. And then they admitted on their website 5 years later, saying, we improved the efficiency of our PET devices. We increased the efficiency of our PET devices by improving the electronics. So at the end, I was right, and they admitted like that. The other thing that I was not wrong to go on BGO, General Electric, for 20 years, they are producing PET with BGO. So they are selling, and they have a good market. If it was so wrong, they would not have a market. Okay? And during all this year, I have been talking almost to most of the conference, IEEE conference, to the leaders and also to the engineer of General Electric, and they could not refute whatever I said in the book. That they had my book, and they said, yeah, it makes sense, but they had the difficulty to convince the marketing. Okay, now all the thing that I'm saying has been patented, but obviously, if I don't have millions of dollars to pay an attorney to defend the patent, last year I saw the proof that the ASIC built by United Imaging, this picture here, is practically my invention of the year 2000 that is covered by this patent, okay? And I asked, at least, did you write into your article, make a reference that I am the inventor? No, and if you look at, there are not many people that, or even none, that have done. And also there is another features that is the neighboring data exchange. No, this is the 1 meter long field of view. And this is again another patent that is 2007. And now after designing the Explorer that is 2 meter, 194 centimeter, and now they are getting to 1.5 meters, exactly. So little by little, United Imaging is converging several features of my book into their system. And the next one, I think that they will drop the LSO that is very expensive and will take the BGO. At that point, it will be a complete It will be the 3D flow, the 3D CBS made by United Imaging. So higher sensitivity. Also the discussion that I had with Siemens in 2002, I said, why, if we increase the field of view from 16 centimeter to 1.5 meters, you get a lot more counts and so on. And they didn't do it because there was no threatened by anybody on the market. But when United Imaging came to the market with the 2-meter PET, they suddenly, very quickly took a 4 PET, 26 centimeter, put it side by side, make 1.6 meters, just to try to keep up with the technology. Okay, now we are at the proof that what did all these 10,000 PET around the world in the market do good for the people, for humanity. The result is from these people who wrote an article by analyzing the data from 100,000 patients, and the result is that there was no difference in survival rate from people who took 1 PET exam or 8 PET exam. So if there is no difference in getting 1 PET exam or 8 PET exam, that is a proof that it's not a big use. However, it creates a big, big market. And this is the table they published, and this is their article. Okay. Now I come to the demonstration of the title. The title is 39 million lives lost in the past 23 years and 69 million more in the next 10 years. So if I would have received funding in the year 2000, then by gradually building a few PET year after year, this is what the table with the algorithm and the calculation is ended up at line 43, year 23, with 39,971,000 people that could have been saved. And now if we go down to the year 30, that will be 108,961,000. So you subtract this from the 39, you get the 69 million more life. And the algorithm that I have used in the demonstration is the same as before, and I will be glad if anybody can comment and make remarks that we can discuss, we can convert, because this is so important to have a discussion and to make sure that we are working for the people, for the public, and not just for receiving grants. And in these years, I have seen astonishing results presented at the conference, but I had an exam myself, and I will explain on the Explorer, and you will see what kind of information is receiving a cancer patient when it needs this machine. Okay, thank you. This is where I went to Grand Rapids in Michigan, and I will provide the next talk, the experience that I had, and I'm still waiting for something. Thank you.
Okay, thank you very much. There's one question from the audience that concerns BGO versus LYSO. BGO has a much larger signal decay constant than LYSO. How do you deal with the pile-up?
The pile up on the high energy physics or the pile up here?
The pile up here, if you use BGO instead of LWISE, or which has a
Oh,
much
okay,
longer
okay.
tail, and then get
Yeah,
pile
yeah,
up.
yeah. Okay. Well, there are digital signal processing to extract the rising time of a signal that is 300 nanoseconds. And I know that the arrival time is an important factor because that establishes the window when you collect two signals, okay? And in my patent, I show that I improved this by first taking an average of signals of not only the single element, but also the surrounding one, okay? And then by doing the digital signal processing, first with the constant fraction discriminator. Constant fraction discriminator, you know what I mean, okay? That is, says
We
zero.
designed those. We designed these things.
Okay, yes. And so, the constant fraction discriminator, DSP analysis, and I come from the experience that I've been recognized one of the experts on DSP. That is why they invited me to give a lecture at Cerner School of Computing. And then the new things that is in the patent is making an average of the signal, not only the single one, but 3 by 3 or 4 by 4, and that allows you to nail down and to get a more precise arrival time.
Okay, thank you.
Excellent. I would say we move to the last talk.
Yep.
It's the end of the day. We're very tired, but
Did we get some time? Did you reduce the?
no, I didn't. I didn't reduce anything.
No, I mean.
Oh, you mean we gained some
the
time?
late? No, we were late 8 minutes.
Let's say we didn't get much work. Well, a couple of minutes actually.
Okay.
Now we're only 7 minutes late, which
Right.
is pretty good actually.
Okay, good.
I'm happy with it. So, okay, so the last talk, I don't want to take all the time we gained, is comparison between the 3D CBS screening and the liquid bio and other screening of cancer procedure.
So, as a scientist participating in a scientific conference with top experts in medical imaging instrumentation and public expert, to provide the most accurate and honest, we must provide the most accurate and honest information about which single cancer screening test that covers all organs of the body is can reduce the cancer mortality risk, okay? And I am interested not only as a researcher, as a scientist, but I am interested personally because I've been touched by cancer and also my partner. One could expect, so no one could expect a more honest information than from someone seeking this answer for themselves, like me and the loved one. So the case involving Jenny, who is here, who had 3 large, between 10 to 14 centimeter, and several smaller cancer tumors found on her abdomen that has been present from 4 to 10 years and went undetected because she had no symptoms. And the other one is myself. I was diagnosed with a basal cell carcinoma in the lower back here, fortunately at an early stage. Following a biopsy, it was removed, resulting in 11 stitches. However, this prompted me to actually investigate the most cancer screening. So I said, if I had a tumor here, what about inside my body? Maybe I have one there too, that I cannot see it. So how can I detect it? I opened my mind 360 degrees, liquid bio, 3D CBS, anything that can obviously is kind of not very efficient making a test for all the organ. $9,000 for the colonoscopy, that is the listing price, okay? If one has insurance, it's less. Then the PSA, and then, you're testing only one organ. By the way, we never find the cancer of Jenny. And so I was really open-minded. But first, I like to present the case of Jenny, that her primary care doctor in February 2021 found that, advised her to take a CAT scan because she had some bloating on her abdomen. And by looking at the CT scan, they found mass tumor, 10 centimeter, 14 centimeter at the ovary. So he logically advised to have a surgery by specialized on ovaries, that in March she had this surgery, and they found, after removing this big and small tumor, the surgeon realized that it was not an ovary cancer, but it was a low-grade appendiceal mucinous neoplasm that had already metastasized into a pseudomyxoma peritonei. So an LAMN into a PMP. And by definition, when it is classified, this is classified a 4th stage cancer because it was metastasized. So in May, the first surgeon, he just wrapped up after removing this big tumor and said, now you need to go to another surgeon specialized on this type of cancer. So she recovered in her health, and after 2 months, 3 months, she had another surgery that is a cytoreductive surgery followed by HIPEC, hypothermic intraperitoneal chemotherapy. The surgery together is known as MOAS, that is the mother of all surgery. Because the surgery lasted many hours, in their case it was 11 hours and 56 minutes, no, because I was there, which involved removing the spleen, the large omentus she just said that it's almost 2 pounds, 2 small tumors at the liver, scraping the pancreas and colon. This was followed immediately by the HIPEC procedure that circulated heated chemotherapy through the abdomen for 90 minutes and killed the cancerous cell that had spread. She was kept in induced coma for several days, spent 2 months in the hospital, 4 months with a feeding tube, and required 5 months of wound care. The most shocking thing was that the experience of the surgeon says that her tumor was present for 4 to 10 years. And another piece of information that was also very shocking is that she never wanted to request a PET examination because she was an honest, very honest surgeon. She knew that it was not giving her any good information. Why? Because it was not sensitive enough. It was not showing anything useful to her. So I believe that a regular screening of Jenny during these 10 years, by recording and subtracting the image year after year, so the instrument will show the growth of this and could intervene before getting a mass of 14 centimeters. Today, Jenny stands at the conference supporting my effort to raise awareness and importance and the cost benefit of effective instrumentation for early cancer detection, and advocating for allowing funding to allow the experimental result be the judge of this invention and not the opinion of people against me. So self-motivation is using bioliquid test. In my case, I said now, if there are so much publicity on liquid bio, I like to take a test. So I went around and I looked at the hospital in Houston, in Dallas, and talked to the doctor. And so I went to well, first they told me to use, where is it, the Guardant, this one, the Guardant 360. And I asked, what is the price? $300. Okay, no problem, that is reasonable, I can take that. But after doing more investigation, it was not for a screening, it was for a stage 4 to determine cancer patient, to determine the appropriate therapy. Then they advised me to take, they recommended the New Amsterdam genomic test costing $2,800. In that case, I said, well, this is something that costs more, so let's investigate a little more. I said, what comes after? After getting the result, for instance, that I have some marker that may have a tumor, what? Oh, it's going to cost more, it's going to be, so I mean that although there is a promise in liquid bio research, and it is a field with potential of many discovery, at present is neither practical nor effective in significantly reducing cancer death. So while this technology can certainly provide valuable information for genomic profiling of different cancer and identify target therapy, it will be very costly and involve a lengthy learning process. This might generate more business in genomic profiling and personalized therapy than lives saved, potentially increasing. So in fact, there is no one, I couldn't find an article, if somebody has an article, that is making a theoretical calculation of how many people can save a screening with liquid bio. Something surprised that Panacea, I came across this several times. The first time in 2007, Time magazine, big publicity saying Panacea, they found a blood test, it means liquid bio, that is very sensitive and save lives. Then I found them again at the World Cancer Congress in Montreal in 2012. And at that point, I went to because they were there, to the CEO, and I said, well, I see that you are claiming 98% sensitivity and 91% specificity on the 4 big killer, okay? The lung, prostate, breast, and colorectal. Said, did you make a test on a specific territory? Just testing your, it doesn't cost very much. Take an area and test it there and show that after 1 year, 2 years, 3 years, the mortality rate is going down. No. Would you do that? No, he went away and never responded to me anymore. So I then tried to, the 2020, 22, I said, let's go to see the future of this, what happened with Panacea Pharma. I called, they did not exist. The website was down. I reached them through Bloomberg, and they told me a reference regarding this company. I called that company, and they said, yes, we purchased this company, but we are not carrying on that test anymore. So that we have beautiful, very highly professionally written article on liquid bio that is funded with millions of dollars. And one of these next generation sequencing in liquid bio, cancer screening and early detection. So they are claiming cancer screening and early detection, but practically I am a customer. I would like to use it, get the benefit, and I didn't know, I couldn't find it, okay? Instead, with the 3D CBS, it's there, it's a machine, it can be built, it can be find the small tumor and can find early detection and is at our fingertip, okay? So for me, after being diagnosed with basal cell carcinoma at an early stage of skin at the lower back, I looked around and I wanted to have a test on a PET with a long field of view because I know the benefit of low radiation and more data collected. So I knew that there was the Siemens Biograph Quadra. I found one in Anderson in Houston and at the Mayo Clinic in Rochester, Minnesota. Finally, I got the register in Rochester and I asked how much it cost. It was pretty high and the radiation, they said 11 millicurie of FDG. I said, no, I'm not going to take 11 millicurie of FDG. So I shopped more around and I found an Explorer in Grand Rapids and I went there. They gave me 4.1 millicurie. By the way, I can sure that it was not a high radiation because I went to the airport 2 hours after the test and the control system did not ring the bell, so I wasn't radioactive. And then they gave me 1.63 gigabyte of data of the exam. And as a normal person, what does it do when it gets those data? Okay. It says, what I am interested is, here is the place where I have the tumor. I like to see the information that you have in that area where the tumor is compared to the surrounding area, okay? Two things, one is testing the machine and the other one is being sure that I don't have cancer anywhere else in the body. And still today, after what is 10 months, I don't have the answer. Nobody can tell me. So this is the thing that we should change, that we should not just work to present beautiful data, astonishing result here at the conference of the sensitivity, of the low resolution, low radiation and so on, but we should, in this case, I am a patient. I want to know the activity and the difference between the place where I have a tumor that has been confirmed by biopsy and the surrounding area. So it's a legitimate question, and I still have not received answer. Okay. One brief thing is 78 years ago, we had a National Geographic, and I have this issue of 1946 that it says the news is good, the death rate is going down. Among women, the rate is being reduced for all forms of cancer. In Italy, it increased from 12,760 in 2016 to 15,500 in 2022. Okay, and so we continue to receive this, and now there are 10 million people dying of cancer every year. It is increasing every year, while we know that early detection is working. So this is, I'm asking for the measure activity of the area of my basal cell carcinoma, and what our goal and task is not to be proud of the sub-millimeter or picosecond PET, but serve science, our colleagues, and the public. Our goal and task is not this. Our idea and effort must be proven by end result, and the end result is not the sub-millimeter PET detector. Is removing this discrepancy. The discrepancy that in United States, the cost of healthcare per patient, per person is $12,000. In Italy is $4,000. And the mortality average lifetime in average lifetime in the United States is 79 years, and in Italy is 84 years. So these are the discrepancy, the thing that is proving that we are good scientists, that we are working for advancing science, for humanity, for everybody, for us. Okay. So. So besides Jenny, we hear all the time, and just last week, my cousin, she died of pancreatic cancer because when she was diagnosed 7 months ago, it was too late and she didn't have symptoms and was not detected by anything. So scientists and decision makers have the responsibility to eliminate this contradiction of really showing to be able to reduce cancer death in a specific area with whatever the project, the idea, the invention that they have. And now, if there is time in here, Jenny could tell just 2 words of her experience, if it is allowed, I don't know.
Go ahead.
Well, I would propose that we can do it after the session. I mean, you certainly will be available here, and then you can follow the discussion with the
Yeah.
audience.
Well, thank you for sharing. Your stories are very touching. This last talk was, many people have been touched by cancer, unfortunately. So thank you also for the other talks. Thank you for participating in this session. Big thanks for the audience. And we close this session here. We have no questions, and we are over time anyway. I now have to run a sprint upstairs because I have another function. So thank you very much, everyone, for coming. Thank you, Dr. Crosetto and Jenny, of course. I wish you the best, and
Thank you.
please continue to enjoy yourselves at the conference.
Thank you. Thank you.